So in this example, we want to look at the region between y equals sine x and y equals cosine x from 0 to pi. So we'll call this 0, we'll call this pi over 2, and this pi. And we know sine x, and we'll say this is 1, and this is negative 1. We know sine x at 0 looks like this, right? We have sine x, and cosine x starts at 1 and is at 0 and it goes to negative 1, so it looks like this. So if I'm looking at the interval, I need to know there's two different parts. We're going to do dx here, but I have two different places, and I need to know where are they equal. So when is sine x equal to cosine x? Because that's our point of intersection right here. Because we're going to have to switch which is on top. Well, we know that that's always when x is pi over 4 in the first quadrant, so I know I have two integrals. I have the integral from 0 to pi over 4, and what's on top here is cosine x, so that's cosine x minus sine x dx. And then from pi over 4 to pi, we know that sine x is on top, so it's going to be sine x minus cosine x dx. Now we'll just integrate it. We know that the integral of cosine is sine, the integral of negative sine is cosine, and I'm going from 0 to pi over 4, and then I have plus the integral of sine is negative cosine x minus integral of cosine, which is sine x, from pi over 4 to pi. Now I just have to evaluate it. So I have sine pi over 4 plus cosine of pi over 4 minus sine of 0 plus cosine of 0 plus negative cosine of pi minus sine of pi minus negative cosine of pi over 4 minus sine of pi over 4, and I have, this is radical 2 over 2, this is 0, this is 1, and this is negative 1, so it's positive 1, that's 0, and this is negative radical 2 over 2, and negative radical 2 over 2. So I have here negative 1 plus 1, which is 0. And I have radical 2 over here, and this becomes another radical 2, so the whole answer is 2 radical 2.